I'm sorry, I do judicial, I'll use these, okay, 5 minutes, 1 minute.
Yes, my name is Judicial, and I teach chemistry education in the Northwest University. Yes, I was a teacher by profession, I was teaching high school chemistry as well. So now I thought that was more on teaching, basically to teach chemistry. So I think we might be aware of many institutional reforms, which there are lots of requests to see how do we teach science, and some people say we have to use empirical-based learning, let's use problem-based learning, because we come to realize that most of the time we talk science, but people don't actually know what they're talking about. Just this morning, one of the presenters said she went to university, she taught for 7 years, and then she left there to go teach in the university. And for the first time, she learned that Kelvin, Fahrenheit, and Celsius were actually the names of the people. Now, I think that's very interesting because we did not necessarily engage with the content. And I think problem-based learning allows us to actually deal with the content. Myself, I've seen in South Africa, you speak with the teachers, and we can all agree that maybe matter can exist in different phases. But if you talk to a person and then you say you had oxygen in a liquid form, in a bottle, people don't get to agree with that. And problem-based learning allows us to actually explore science in this case. So in South Africa, as we said, Department of Education have stated, not in specific topics, but in just the one document of the curriculum to say, let us use problem-based learning, let us use empire-based learning, and let us use simulations to teach science, but they are not specific which aspects of science must be. Although for third simulations, they are specific on topic by topic to say simulation, these ones must be used. So we know that problem-based learning has been taken as one of the influential ways for empirical-based learning, in which we use an authentic problem that people have experienced, and then we can explore the problem. So what it actually means, I think I like also the other presenter, this one who said, when you do some of these projects, you have to partner with the communities so that you can actually get the problems that the people experience. And then even now, when you draw up some of these problems, problem-based learning, you first have to know the students that you are teaching and the problems that they face. So if you were talking to a student in South Africa and then you tell them about the snow and jet ski and all of that, does not make sense, because chances are we never had snow, we've never seen snow. So that is not going to help them to learn science. So now problem-based learning need that problem as a context for the investigation of what they actually need to know. And unfortunately, science teachers avoid implementing problem-based learning simply because there is a lack of knowledge. Literature tells us people don't have knowledge on how to use problem-based learning. Some of the issues also is because they don't know how to deal with the problem part of problem-based learning. Because problem-based learning, it needs a problem. But now, where is the problem? How do we get to the problem? How do we decide the problem or the activity? Because it means now for each and every topic, you need a particular problem that learners or students can explore in order to actually engage with the content. Now, looking at this, I looked at we used ZPTD, Zone of Proximal Teacher Development, as a maybe a theoretical lens to help us, because we are trying to expose science teachers to problem-based learning. And it's the distance between what the teacher can do with and without scaffolding. So we know that we have different types of scaffolding which are there. There is hard scaffolding, there is soft scaffolding, and then we have to match them accordingly And looking at the previous presentation, we so much about professional development, need to look into that. And now ZPTD gives us the 4 stages on what can be done. And it's much more specific because it speaks to how we can assist teachers in 4 stages to actually learn how to do something. Now, I had really a serious battle to say, exactly when you propose a framework, where do you put it? There has been, I looked at so many debates. I've asked also many renowned researchers, and they also were debating, no, it depends on what it is for. You can put it at the beginning, and then you can show how it works inside. You put it before methodology, you can put it in the methodology. But you can't put it right there. It's not really so there has been lots of debate. So I wanted to say, I'm putting it here, and I will speak to it as a, but it will talk to the Z. It will talk to the Z BTD, the scaffolding which must happen. It will also talk to the resources that you may need, and of course the model in terms of how do we actually deal with this problem-based learning. Everywhere we go in here, problem-based learning, but we do not really understand what they're talking about. So in this intervention-based study, it's a bigger project, and then there was just a lens to include on the quantitative aspect of the one that speaks directly to the model. So the study was conducted in one of the 9 provinces in South Africa, the Northwest Province, and the province there is divided into many districts. So then we had these districts were taken as clusters, and then cluster something was followed, and systematic. So, and then we had a total of 40 science teachers. So I will not go deeper into it, but this is, as I said, it's from a bigger project, which actually was following the mixed research. Now, the 2 critical data generation instruments here was one which was adopted in a study in South Africa on using simulations, and the other was adopted from the United States, talking on problem-based learning. And of course, this will use the SPSS to analyze the data and also the rubric for dealing with the reflective portfolio in a quantitative form. Now, in this intervention, a 3-day intervention was done with these science teachers. And participants were working collaboratively as they would be expected when they're implementing problem-based learning, because learners would be expected to work in groups. Because many times even learners may prefer to work alone. It's very nice to work alone in school. There are no issues, but in the world does not work with alone, with people. And so these groups must be 6, and of course, taking a lot from the ZPTD. And the participants are advised to remain in the same groups for the entire time of the intervention. And it is not worthy to mention that to give a close focus on how we implement problem-based learning, the topic of the 3 states of matter was used so that we can implement it. So many times we see people can say problem-based learning can work. Does it work everywhere? Does it work with everything? I don't know if it works with everything. I know it's a very good strategy. And I can definitely tell you, it is a very good strategy to teach the 3 states of matter. So, and this topic is a topic that is being taught in all science across the world. Everywhere you go, you will see the 3 states of matter from SLM grade 6. Maybe, and they just took in 3 states of matter. It is surprising that if we talk about 3 states of matter, repeat, yes, solid, isn't it that simple to teach it all the way from grade 4, grade 6 until grade 12 to university? So special about it, is it easy? So but you'll be surprised that it's probably one of the most difficult topics has chosen for this. And how do we deal with this problem-based learning? How do we design? Because we're trying to address the problems that we are saying are coming with problem-based learning. We have to plan this problem-based learning by first creating a problem that or activity that we have to work in. How do we then create that problem? So then we look at there's a model here, like which is called a systematic method, specifically designed to guide instructional designers and educators for effective PBL problems in all levels. But more recently, the same author modified this model to second generation 3C3R problem-based learning model. So with this model, the 3Cs there talks to a problem when you work with the learner to teach them science. This program must have the three important C's. It has to speak to the context that these learners are exposed to. It has to have the content that you are trying to teach, and there has to be the connection between the two. It goes then to speak about the arts, the three arts. There has to be, it should leave a room for researching. It should leave a room for them to reason, and they should be able to reflect on what they are saying. It goes deeper, it has some components right now, the first teamwork, and the problem has affected the people, because if the problem is not your problem, arguably, if maybe, for instance, there is floods in Italy, there is no floods in South Africa, and you ask me to solve the problem of floods, I'm sitting in South Africa, I don't have that problem. It's kind of difficult to deal with the problem because I don't have the problem. So that's why this model was much more relevant. So these are those components that we are speaking to. And of course, as I said, then we have these enhancing components. Does the problem affect them? Is it the level of difficulty is fine, and also the teamwork? So with that being said, there is a lot, I think, that one can look at in terms of this problem in the framework, because there isn't the problem is there is no framework which we can look into to see and compare to this one. So there was not much to draw from in terms of the framework, but there is a lot to draw from in terms of problem-based learning. There is also not much to draw from in terms of how do we implement the problem-based learning, because things are there, but there is no blueprint to say, here's the direction. Everywhere, I think in the previous presentation, we say that they are not able to use maybe good strategies. And when you come to check, there is no part in the curriculum where they say, this is the topic, this is the strategy that you must use. That's why the policymakers don't care about the strategies, they just want the marks. That's why now teachers use exam and then give them the answers every day, every year, whole time. They just focus on the question and how the answer is. So, but all in all, the same way able to find, teachers were able to actually using that model to create PBL programs. So what it requires is now, it's a bit demanding, to be honest, for a teacher to know. We saw the previous picture of one location in South Africa. You find that's just a bad place for a person to stay. A teacher does not stay there. A teacher goes there just to teach and leave, goes back to the suburbs. Now, the teacher will need to know the problems that these kids are experiencing in this particular section for them to actually be able to come up with a problem. So it requires that from the teacher. But nonetheless, in my case, Northwest Province in South Africa is more, I think this side they would refer to the rurality more as the, I think they call it the countryside, something like that. So it's kind of different than to the context. So even the problems that teachers were staying, in my case, my province, most of the teachers were staying in communities where they teach. So the problems that are experienced by the learners experienced by the teachers, they know the places, they are able to actually draw out the problems. And the learners were able to engage with the problems. And yes, there were many other findings. I think there's been about 4 articles which have been published in different journals from the study, talking to different segments. So this was just the one final segment which was missing to talk about the real problem also that there is no looking. And with that being said, I would like to say thank you very much. And that will be the end of my talk.
Okay.